sure you already know this, but tell you something. This guy will leave you on the side of the road. Welcome back to Toss a Coin to Your Tech Guy. I'm John, your tech guy. Today we're working on this monster. This is my 1995 F350 7.3 liter diesel. It's not quick or flashy, it gets the job done. This is the workhorse of my rusty fleet. However, it let me down yesterday. The fuel tank switcher decided, hey, I don't want to switch fuel. And so I actually ran out of gas taking a cow in for my father-in-law. And today we're going to go through how to change it, how to diagnose it, and a teardown video of how that thing works on the inside because it's really interesting tech. Not only does it switch between tanks, it actually changes the tank that is sending signal to the fuel gauge, which is awesome, awesome tech. It's all based on resistance, but we're going to get into it. Some of the more astute viewers may have noticed something on the back of the truck during the intro. We have three things here, and these three things are what we're going to use to repair this vehicle today. The first one is a battery. So yesterday, when I was trying to get this thing back on the road after running it out of fuel, I had to run the air out of the injection lines. And on an old mechanical 7.3, that actually involves cranking the motor over periodically to move the air out of the system. And you have to crank it over fairly quickly for the high pressure oil pump to actually engage and fire the injectors and push the air out of the system. Unfortunately, one of the batteries on my truck is a little iffy, so we're going to change that out. The second thing we have here is our new fuel sender. This guy we're going to get into under the truck, but if anybody is wondering, this guy is a Dorman 904454. This guy will replace pretty much any 7.3 fuel sender, I believe, from about 1994 and a half up to 2003, if memory serves. I'll put a note in the video later if I'm off when I go and look that up. And the last thing we have here is our fuel disconnect tool. Now, I have a few of these laying around. They're all boogered, so I went ahead and got a new one for this video so that we can all work together on this and hopefully not take a bath in diesel fuel, at least not quite as bad. Now, my old 7.3 uses two batteries, and one of the easiest ways for you to test these batteries is with a test light with voltage built in, but being a tech guy, I like voltmeters. So we're gonna put this thing on volts. We're gonna make sure it's set to DC. I don't know if you guys can see that, but it is set to DC. And then we're going to test the voltage on this battery. And you can test it either way. Just remember that if you reverse the lead, you're going to get negative voltage, which might confuse some people, but we're going to test it the right way here. So I'm going to put this way so you guys can see, and then we're going to actually attach both leads to the battery, and we're reading out at about 11.6 volts-ish, which is actually sort of kind of okay, or would be if this wasn't the battery I know was bad. However, if we go to our second battery over here, we're going to notice something a little bit different. So if you look, the second battery I've already removed the cover and cowling for because these 7.3s actually came with an air duct on the other side here. And the air duct was originally an air dam to feed this filter. I put an aftermarket filter so I could actually reuse that guy. And if we look here with my expert camera work, we can see, oh yeah, 12.5 volts. So that battery on the other side is just a hair weak for our purposes. So we're gonna go ahead and swap that guy out. If you guys are not an idiot on YouTube telling you how to do things with no apparent warranty, or if you're just not experienced with this, I highly recommend safety. So the first piece of safety advice I'll give you is don't cross those terminals unless you like welded wrenches. It will turn hot, it will probably brand you. I've been branded by throttle cables before, getting those across the positive side of this thing. And the other piece of safety I would advise is don't arc these because over time these batteries will release gas. That gas is highly flammable. And if you do arc these, you're going to end up with a situation where, you know, kaboom. And none of us are Marvin Martians, so we really don't want an earth-shattering kaboom here. As we take our old battery out, we're going to set it down very carefully, make sure it's vertical on the ground. I did it off camera here, but you guys can figure that piece out for yourselves. And then when we put our new battery in, what I like to do is leave one terminal covered as I put it in, so I don't end up arcing. Big battery. I don't end up arcing anything to cause a spark. So if I hit this negative terminal on that one, it won't cause a spark. A lot of guys like leaving the positive terminal covered, and that is perfectly valid as well, and probably a better approach. But again, I'm an idiot on the internet telling you how to do this. Always, 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 always reinstall your battery tie downs. I can't tell you how many guys I know that they'll leave these things off, and well, their hoods look a little scarred because they'll hit a big bump and arc to the hood. So always put your battery tie downs back, folks, because if you don't, you're going to end up with some arcing happening there as you hit a bump. Also, the battery doesn't stay stable and jimmies around, and you might pull a cable loose or something else terrible might happen. So secure these things down, and you don't have to do much. I'm using a 1/4-inch ratchet here, and it's nice and tight. So as we put these terminals back on, I'm gonna try to loosen that guy up there because he's being a little stubborn. Excuse the arm. Yeah, there we go. All right, I'm gonna leave this on loosely so I can get it back off. But as we put these terminals back on, it's most important to make sure the insides are clean here. I did pre-clean these off camera, so before you guys getting too big of a tiff, they are clean. But when you put them down, in this case I'm using a 1/2-inch wrench, you want to make sure that they're tight. Maybe not extremely tight, but firm, such that you can't twist them around. The reason for that is because with all electrical components, conductive surface area is very important. The angry pixies in here like having a nice path to go through here. So we want it nice and firm, there we go, so that I can't move it around too much. And as we put our negative cable on, you might see a couple of angry pixies escaping from the battery, but you shouldn't see too many. Different batteries have different terminal sizes based on wear and or manufacturer, so you might have to loosen this and wiggle it around or whatever the case may be to get it down. The important part is that you maintain conductive surface area, and that way you don't, end up with a check engine light that's not on the dash. In this case, your terminal might get a little crispy if you don't get this down nice and tight. Okay, so there we go. Got that guy. I'm gonna go ahead and secure the other guy off camera. We're gonna see if this makes a difference. I bet you it'll wind over faster. All right, here we go. Glow plugs are on, heat cycle's going. Let's see if this old monster will come to life. Ready and go. Yeah, like butter. She's a little cold, but there it goes. Perfect. All right, so now that we've got that fixed, let's fix the actual thing we came here to work on. Side missions are a thing, guys. Okay, so we're going to test the fuel sender. My first tech tip for this video is get yourself a set of these guys. These are godsends, especially when you're doing electrical troubleshooting like this. Alligator clips make the world go round. Now, if we look here, I've already pulled the connector out of our fuel sender, and if we look at the colors of wires on the back for this particular application, you're going to note that there are 2 yellow wires here. These are for your front and rear tanks. Now I know both of my tanks are full, so they're going to be over 160 ohms per at these wires between ground and the connector right here. So when we set this up, we set our multimeter to ohms. That's the omega symbol here for you non-elect chickens. And then if you jam our probe into this connector carefully, trying not to break it, we're going to notice that this is going to start reading out at over 160 ohms for our sender. Now this sender right here that I'm reading at the moment, I believe is the rear sender. So it's reading a little bit high, but it's still reading. And it may be just a bit over full actually. And then if we look back here at the front sender, it's more in the range what we would expect, just over 165 ohms. And that can be attributed to rust, my ground point, whatever the case may be, because I just cleaned a ground point here on the frame and connected my alligator clip. But we at least know both our fuel senders are outputting. So that bit is good. Now the signal going back to the gauge over here is the problem. And these 2 wires actually run through the switcher up here. And so when you swap tanks, they change the connection between the 2. Okay, so the 2 bolts you're going to need to take off the sender are right here. These guys are 10 millimeters. And your next tech tip is get you a set of these guys. These are godsends, especially in hard to reach places. In this case, I'm cheating a little bit because I already loosened these, but we're going to rip these off, get the sender dangling, and then we're going to worry about disconnecting the fuel lines. Okay, like with everything diesel, nothing is clean and nothing is easy. Here's our old sender, and you can see it's got several ins and outs on it. These are all keeper style O-ring fittings like regular fuel line. So I didn't actually need the disconnect tool, but what I did need to do is be very careful with the plastic keepers on this thing. And I did the swap off camera because, as you can kind of see, well, things got messy and my driveway looks like the Exxon Valdez was here. Now, up here on these guys, on these little plastic keepers for each of these lines, it's going to be a prong fitting like this, and it's going to slide into the fitting and hold it in place. It's literally just there to keep it from falling off. So what we're going to do here is I've got this connected, all the fuel lines are secure, I've got it hang tested, and we're going to see if this guy works. And I think it will, and then after we get done with that, the juicy bit happens and we'll tear this guy to pieces and figure out how it ticks. Okay, now that we've made a giant ecological disaster and got this thing all buttoned back up and the batteries have been reconnected, I'm gonna leave you guys under here and let's see if it switches. All right, here we go. I'm gonna go turn the power on now and we should hear a little ka-chunk from down there below. There we go. Yep. Seems to be actuating. It also seems to be a little upset. What is your deal here, little buddy? That connection. We're gonna have to clean this thing. This connector right here is nice and dirty, so it's not making big contact. So some of my friends do get on to me a little bit. I like using the good stuff. I like CRC. They make great products. I'm not affiliated. I mean, unless you want to reach out, CRC. But yeah, this stuff, great. Their brake clean products are great, but I love their contact cleaner and the dielectric grease. So what I like to do is like to hit this guy's little contact cleaner, let him dribble out, dry out nice and good. I'm also going to hit the connector right up here with some, if I can see what I'm doing. Hit. Oh, miss. Try again. There we go. Got her. And now after I get done with that, and these things drip dry just a little, what I like doing is putting a little spray-on dielectric grease in these things. Now what this does is this is nice to the next guy. Be nice to the next guy, because you are the next guy. And so what we're going to do with this stuff is, you know, let this thing dribble out a little bit more. I might actually rinse this off some more because it got quite a bit of diesel fuel on it. And diesel fuel is probably not terrible for keeping this thing lubed up so we can get it back off, but you know, let's be nice and clean it up. That said, this stuff is great. I spray this in all the electrical connectors on all my old stuff because these little guys are as old as I am and or older, and they will break. So if I'm nice to the next guy and I lube that thing up so that it'll come off nice and easy, next time I do this job, not as bad. So I'm gonna take this and give her a little squirt and kind of get it on the contacts and in the connector itself here, so that it has a nice lubricitous surface to get in on. And then I'm gonna do the same thing with this guy here eventually, if I can get this stuff out of the way so I can see what I'm doing. Now you're gonna see a bunch of it fall out, and that's okay. What we want is we want to wait just a second for that to dry. It's going to turn into kind of a white powderish substance, and what that does is that helps moisture stay out of there and prevents corrosion, a few other things. So it's actually a really good thing to do for our connections, especially on an old rig like this where she's clearly been together for a while. But what I also like to do is I like to put it together a little bit before it's dry, so that when it does dry, that grease has a good enough chance to kind of get in there and make a moisture barrier. All right, so we got that in there. Let's give this one more try. Hey, that sounds a lot better. We're actually going between the tanks, it sounds like. Make sure this connector's nice and seated. Seems to be. Give her another test real quick. All right. See if she'll prime right off that. Tank, which before that didn't work.
Here's one of those symptoms I was telling you about under the truck with the resistance value. This is the rear tank. You notice how it's reading a little past full now. That is a symptom of that high resistance on the sender. So what's going to end up happening is I'm going to run all the fuel out of it and back up, and the computer will relearn the resistance range on that particular sender. So don't get scared if you see this. This is fine. It will go back down. Don't worry. Just 4 things, guys.
Okay, now a lot of you are expecting a tech guy to go off and have a fancy place to tear these things apart, but for today's purposes, we're going to use the back of the brick. And the reason for that is because this thing's full of diesel fuel. My garage isn't right now, so we're doing it here. So this thing's held together with 4 brads. You can see them here, 1, 2, 3, 4, and then 2 little plastic clippies. And so what I'm just going to do is I'm going to drill out these brads on the back so that we can get at her and see what this thing's made out of and what juicy technical details exist within. If you're following along at home and wincing at the camera as I do this barehanded with a drill, remember, I'm an idiot. Do not do this yourself. If you choose to do this yourself, I am not responsible for you catching yourself on fire or whatever else the case may be. Now, diesel fuel's not incredibly flammable, so I don't think you're going to kill yourself out of hand. But do what you can do. Do what you feel like is safe. Me, I'm dumb, so I'm just going to send it. All right, so I got 3 out of 4 to poke through. This last one's being a little stubborn. Let me see if I can get in there a little better. We don't really care about the housing on this thing now because we got a new one. There we go. That's popped through. All right, now that we got that out of there, let's get our little clippies. And that little clippy stuck down in there pretty good. You guys can kind of see it behind the bracket. I need something. I think I'll just use my truck key because that's high tech, right? Let's get in here. Yeah. In here, see if we can push that forward. Come on now. Sometimes these are a little stubborn. There we are. All right, so this top housing should ideally come off here, unless something else is holding it that I'm not aware of. Or maybe I just need to be a man. The answer was be a man. Ooh. Wow, look at all this. My mind is boggling. Okay, check this out. The first thing we got in here is, if you can see back in there, I'm going to try to get close to the camera so you guys can see, is we have a small PCB with a couple, looks like 2 diodes and 2 signal wires here controlling a DC stepper motor. Now, most likely on this guy, the reason it wouldn't swap between them is this stepper motor eventually went bad. And I can prove that with the valve body assembly here because it moves pretty freely. It's not bound up or anything. But interestingly, the way this thing is put together is that when you have it together, you see the contact pads on the bottom there? Those contact pads then index onto these 2 contacts here on this rotor. And this rotor will push up against whichever contact pad is currently engaged. So when the stepper motor engages, flips over, computer then sees the signal on the wire and knows, oh, this is engaged, we can stop now. Very interesting, very cool. Let's see if we can get into the valve housing here. That might be where all the really cool tech is happening. Well, we can, but there's some lock rings here. I don't know if I really want to break them out of hand because this is just such a neat little piece of mechanical engineering. But what is basically happening here is that when this thing screws in, notice it turns pretty easily and there's an actual threaded piece in there. it's actually moving the position of the valve between the two tanks. So you got source and return for one, and you got source and return for another here. And then this being our out. So the valve is actually moving between these two to tell, or to actually select which tank we want to actually use, which is really cool. Look at this thing. I mean, it's very simple, and it's very clearly, you know, fuel-resistant ABS, and it's not what you'd call incredibly skookum, but it does the job. And as far as I can tell, this is the original one that has been in there since 1995. So that just goes to show you, folks, simple is good. Keep it simple. Simple tech is cool. I mean, look at this thing. There's nothing to it. It's just a few contact pads to tell it, you know, what position it happens to be in, and a little stepper motor. That's it. It's the whole thing. Ha! Bet you guys thought the video was over. Not so. We still have to go through this thing. This is actually a nice, cool little piece of tech. We're going to take this apart, go through it together, discuss the components, and I think we might be able to find a sneaky way to repair these if you got a little screw that'll go through this, and if you're not like me and you made a ham-fisted mess of drilling these things out. Which my ham-fisted mess is around here somewhere. Let me find it. There it is, right there. But I could probably still make this guy work. Let's see. I think the first thing we're going to have to do is we're going to have to get in here and get these little lock rings out. You see them down there? That way I can slide this PCB out and get that little stepper motor out of there, and we can actually go through how this thing is really supposed to work. Because this bit's pretty simple. This is a plunger valve right here, and we can go over that as well in a minute. I'll take this apart and get these little lock rings out. Bear with me. Alright, sorry about that. I had to reposition you guys so that, you know, we could all see the insides together. I'm going to try to work these out with just a pair of needle nose, but I may need to go get a pair of either lock ring pliers or just a screwdriver, see if I can get these out. But we're going to try to work them loose. Anyway, while we're doing this, let me tell you a little story. So, when this thing actually went, we were right next to a high school, and there was a cop across the road. And hilariously, the cop did not seem to mind that we were in dire peril of having ran out of fuel with a cow trailer on the back of my poor diesel. Well, so enter our struggles with a jump pack and a iffy battery. And when that all failed, there was a nice fellow that swung by in an electrician service truck. And this fella, and this is proof there are nice people everywhere, came and offered to give us a jump, which I had heavy-duty jumper cables with me. And when that didn't work, because, you know, naturally there's air all in the lines, and it took forever to wind all that out, he actually gave us a tow to the nearest gas station. And I keep a chain in the side of the work bed on that old truck for obvious reasons. And, well, so the chain worked very well. What didn't was the wild ride we took to the gas station. So as we're going along, this guy continues to accelerate. And as he accelerates, I realized two important things. One, I've got a trailer on the back of this already heavy truck. And two, I no longer have power brakes. So, me being me, when we get to the turn for the exon, I put both big feet on the back of the brake pedal and press down as hard as I can. Naturally, the whole thing comes to a stop, screeching halt, including the truck in front of us with the electrician service bed on it. And I actually felt really bad about that. So if you're out there, guy, I do apologize for that one. But we did get into the exon, and he did actually tow us to a nice spot to troubleshoot and work on this poor little thing. And he even towed us through the pumps to get diesel, because my working theory was that, you know, since we ran it dry, we needed to get some up to the pickup so that we could get air out of the injector lines. And that turned out to be 100% correct. But hey, if you're out there and you're listening, appreciate you, guy. I'm not going to shout out your name because I don't know if you want that kind of publicity or not. I'm a smaller channel, so I'm not terribly worried about it, but you know, I'm just trying to be nice to people. Remember, kindness is free, guys.
As I work this out of here, you're going to notice that most of this is held together with just little soldered on or staked on wire. It's actually not that complex of a setup here for me to work with. And I may not try to work this out because I'm going to snap it right half in two and kind of ruin our explanation. All right, so now that we're into the guts of her, we can see a few different things. And I'll try to get something to point with real fast. A piece of wire will do. All right, so the first thing we can see, and I'm going to try to hold this up to the camera so you guys can have a look-see, is, come on, focus, there we go, is two little diodes. Notice that this stripe on the back side of the potted component, or in this case, discrete component, indicates a diode. And this one I broke getting it out, so don't think that's the cause of failure. That's me. I'm ham-handed. But this stripe indicates which direction current can actually flow and which direction it's blocked. So in this case, it's allowing current to go this way, but not back the other direction. And this is pretty important because the computer on the other side is obviously reading this circuit. Focus. Okay, I'm going to have to hold my hand there. And you don't want to fry that guy out. So having this protection diode in here is actually a really good thing. The other thing we can notice is the contact pads. So these two pads, these two big ones, these indicate what position the actual pump is in as these contacts here on the actual valve slide past. Now this is just a screw device that screws this bar mechanism in and out. And we'll take this apart in a second. But as that thing screws in and out, the stepper motor here is what's actually doing the turning. And this guy, I don't know, I thought it was locked up, but no, it's free. So I'm going to take my variable power supply here in a minute, and we'll see if we can't make this guy go burr just for giggles. Looks like in line here, we've got another small component. I believe this is probably a resistor of some kind to ensure that the motor doesn't spool up to full chooch right off the hop. But I'm going to have to look this part number up, and we'll see what we can see there. Now, as we were talking about yesterday, we were talking about the various positions and the way this thing actually reads, if I get some light, actually reads through to tell you the fuel level. And if you remember, these two contacts out here to the far right were our actual fuel sender pins on the actual plug, as you can see, that goes through the housing here. And those pins, since this is a dual-sided contact, will make a circuit depending on which one of these contacts is, or excuse me, which position these contacts are in when they, right across the pad here. Now the good part about that is that you're only reading the fuel level from your sender that you care about, so you're not getting a false reading. So as this guy changes tanks, it also changes the sender, and it's a very simple circuit because as this guy wipes across like so, circuit is completed. The overall mechanism here is very, very simple. You have a screw that controls the depth of the valve, and I'm going to run this out just a little bit so I can actuate the valve and show you guys what's going down. But essentially, if you press it in, I said press it in, I didn't run it out far enough. There we go. All right, so if we press in, we're going to go to one tank, and pull out, we're going to go to another. And you'll notice here on the on the selector housing itself, we got source and return for multiple tanks. So this guy's got source and return for this guy, and this guy's got source and return for this guy. This guy, I believe, will be your front tank. This guy will correspond to your rear tank, and these guys are universal out back to the actual motor. The plunger valve in here should be a fairly simple mechanism, and interestingly enough, diesel fuel that can leak past is actually kept out by a gasket. You can see him there. That rubber gasket here, if this plunger ever fails or leaks, will keep the diesel fuel out of the mechanism, which is really good because I don't think this little guy would react very well to getting immersed in diesel fuel. So that's kind of how this works. We're going to take this pump assembly apart here. I'm going to talk just a little bit more about how this sense system works, though. The sense system only has 2 pads, and you can see that they correspond to 2 pins down there in the actual housing that correspond to 2 pins on the outside here for the plug that goes back into the truck. Those 2 pins are actually being fed into the ECM on the far end, and what that's doing is that it's telling the ECM when to toggle this motor on and off, so when to energize this circuit right here. So when the circuit is on, obviously the pump motor will move between the two. Now when applying voltage, you can clearly see down there that there's 2 different wires. So this first wire will actually provide current and voltage to the motor, and this second wire here, this guy's our sense. So depending on what position the pump is actually, or in this case the fuel selector valve is actually in, is the pad that's going to be energized, which runs through these diodes as we discussed just a minute ago. So according to the other end, it's a simple binary logic. If 1, so have current, so if this pin is high, we're on this tank. If this pin is low, because we can't go through that diode, and we can't go through this diode, and we're in this position here, we're in the other tank. So according to the computer, if it sees high, it's going to be in one position. If it sees low, it's going to be in the other position. So when you flip your toggle switch inside the cab, what you're doing is you're essentially energizing the motor and telling this thing to move until it senses one of these pads make an actual circuit, either high or low, depending on what position you have actually.
Hi, Future John here. Past John is completely wrong. Do not listen to him. This circuit is a lot simpler than I initially thought. I was thinking a more modern vehicle, and this one is clearly not that, being, 30 years old. In this particular case, what's actually happening is that these 2 diodes make a switch. And so on this schematic diagram, you can see that when the switch is in one position, the circuit is energized to a point. And those 2 pads that you saw on the PCB are illustrated here by these 2 dots. And as they move between them, they get to a position where the diode will actually block current going through the circuit. And that's how the tank switcher finds its position. There's no ECM involved. This is all caveman. Additionally, the fuel gauge doesn't go through the ECM either. It's just based off straight up resistance. So if you notice here where the fuel senders are illustrated, they all push back through the switching pins we just talked about to the fuel gauge. The fuel gauge itself is just reading the resistance value of these guys with relation to ground. That's it. Full stop. Very simple.
Looking further at our motor here, we have just what appears to be a standard 12-volt motor that's pigtailed in here with a small resistor in line to control RPM. Probably if I applied full amperage to this, it'd run like a stabbed rat. We're going to try that just to see what's what. But interestingly, on the motor itself, we actually have a little thrust washer here that will kind of ride on the back of this plastic component right there to keep things from wearing out too fast. Now, if I had one of these apart and I had an electronic supply store nearby, I bet you I could find one of these little motors at about the same spec. Now, the downside is that our good friends at Ford did not put any identifying characteristics on the stepper motor at all. It looks to me like this stepper motor is just a standard DC motor. And when I say stepper, steppers generally have positions they go to. And I'm calling it a stepper because of the positions on the pads. Really and truly, this is probably just a bidirectional DC motor, so it just cares about polarity. So what we're going to do is we're going to run some power through it with our benchtop power supply here and see if we can blow it up. Make it turn. I've adjusted our power supply so that when I turn on the actual feed, we're going to be outputting around 12 volts DC. So as I ramp up the output feed, we're going to notice this little guy. Yep, there she goes. She's starting to move. Now, if I add a little bit more amperage to it, the speed increases quite a bit. But I'm only running this directly to the motor. Now, our theory that it is reversible can be tested very simply. So I'm going to go ahead and turn back off the current here and very carefully reposition my alligator clips. Remember, guys, alligator clips save you, especially on electronic stuff. And we're going to see that I bet you it runs the other way. Let's find out. Yep. So this guy's now running this direction, whereas before it was running the other direction. So this is a reversible DC motor. Pretty bog standard. And what I'm going to do now is I'm going to try to make contact with the pad over here and simulate running a certain current at a polarity through this guy. So the way that this actually works in terms of running backwards and forwards is that the computer on the other end just swaps the polarity. And when I say computer, I'm using that term very loosely. It's essentially a potted component with a few PLDs, but for our purposes, it's a computer.
Again, not a computer. Past John is dumb.
We'll see what we get. Oh, very interesting. We're not getting anything. Oh, there we go. I just wasn't making contact. Okay, so I'm going to increase the amount of current this thing can pull by just a little bit, and I think what we're going to see is that it tops out. Too many volts. All right, there we go. Looks like she tops out at about 0.1 amps. That's pretty standard for these little guys. If I reverse this now by turning back off my current draw and swapping my alligator leads, I will bet you it runs the other way, but at about the same current. So I will test this in a second, but I'll bet you this is a limiting resistor right here. Here we go. Yep, sure enough, it's going the other way, and we're pulling about the same amount of amperage, maybe just a hair more. Keep in mind this motor's probably been in there since 1994, so yeah, she's got some wear on her. All right, so let me get my multimeter real fast, and we're going to see how much actual resistance is in line here, just for reference. And then we're going to talk about ways to swap this guy out if this is indeed bad. And in my case, I know this guy wasn't the problem. It was actually a stuck valve. To complete my story about the guy that stopped, he was actually waiting around to go service outages from the latest thunderstorm, and I offered to buy that guy coffee, I offered to buy him soda, offered a 6-pack of beer. I offered everything I could, but the guy just would not accept any kind of recompense for helping us out. And that just goes to show you guys, kindness is free and kindness is everywhere. Be nice. It'll pay off in the end. All right, so here we go. We're going to add in some resistance, or excuse me, measure our resistance. Just like our good buddies in Star Wars. Let's see if I can get this propped up here so you guys can see. All right. So, I'm going to go from one side of the pad to the other side. What kind of resistor do we have? This appears to be not much of a resistor that way. I'll try the other way. Interesting. It's not a resistor. So what is this thing? It's a ST22 Golf 8. Whatever that is. Very cool. Okay, I'm going to look this up real quick. I'll be right back. Okay, dudes, I'm back. This is not a resistor. This is a thermal protection circuit. So these things are really neat because they're self-resetting. So when this guy gets to a certain temperature, based on how hard this is running, this will reset the circuit such that, you know, we don't have melty bits near fuel. This is actually a really good idea. I was completely way off base. I thought it was limiting how fast this guy was turning, but it's not. However, the speed this guy turns then has to be limited by the feed that it's getting from the other end, up near the ECM. So the ECM is only providing a certain amount of current to this guy to turn this little motor. Very cool. So if you guys ever pull one of these apart and you decide to repair it and replace the little DC motor here with something that, you know, might fit from your local electrical supply store, make sure you put this back, because if you don't, fire is bad. All right. See, we're learning a lot today. Tech is so cool, guys. All right. So here's our plunger setup. Our plunger setup, come on, focus. There we go. Our plunger setup is actually held back by these two little locking rings here, kind of similar to what I pulled out to get this motor out. And you know, me being ham-handed, I kind of buggered these up. But I bet you we could flatten them out and make them work again if we chose to put this back together. Oh yeah, oh yeah. There we go. Good as new. If your new isn't too good. Alright, so let me see if I can get these out with maybe a little bit less of, you know, ham-handedness. I guarantee you I won't. But, we're going to try. So the other story from the day that this decided to go out is that the cow we were delivering, she was already out of the trailer, so nobody worry about the cow. But the trailer itself, when we got it home, oh, I'm blocking you guys' view. When we got it home, I discovered that the cow had left a small little wang in the tailgate. She was a bit upset to be transported, and you would be too. Yeah. Well, maybe not. Come on. Alright, ham-handed time. Everybody look away if you're squeamish. Here we go. Oh, almost took you guys out too. The coolest part about these kind of mechanical devices from the 80s and 90s is that there's such a hybrid of modern tech, e.g. diodes and resistor quotients and, you know, ECM control, and just straight up old school mechanical advantage, we'll call it. Because the simplest device on planet Earth is the inclined plane. If you're a fan of Ave, and I'll link his channel later, because I'm kind of ripping off his shtick here, pulling us apart. He will tell you that the inclined plane is the most useful thing on the planet. And what I will tell you is that these snap rings are the most annoying thing on the planet. Ah, come on! Yep. Mm-hmm. Well, that's one. Hope you guys aren't bored yet. Alright, here we go. Try the second. Come here, little guy. It's time to evict you. No, I said evict. I know you've been in there for 30 years, but it's time to come out. I said leave. Dude, do I gotta get the sheriff? What the heck? Alright, there we go. Okay, so here we go. We got our plunger assembly apart, and the inclined plane I was talking about is this little screw mechanism here. If I can get this thing to focus. This is what actually pushes and pulls on the plungers to change between the tanks. So as this guy runs itself out, it's pushing against this radius, or this deep tent here, correction, not radius, deep tent. And it's indexed on the back of this stepper motor, like so. So once this guy is down flush, I'm not going to put it all the, well, I guess I can put it all the way. We have an object example. Here we go. Once it's down flush and the stepper motor's turning, this guy is what's actually moving the valves between the tanks. So we've got a piece of more modern technology married to something caveman. Very nice. I like it. All right. So inside of here, as I mentioned, we have our rubber gasket. Let's save that guy. These guys come in really handy to cut pieces off of. These fuel-resistant rubber gaskets are great for making small engine repairs. Turn this guy off before it starts beeping at me. And then we've got, we've got our valves, but look at this now. Look at this now. Let me get some light. Look at those retaining rings. Boy, these guys didn't want this thing coming apart. Well, I wouldn't either. It's in fuel, so, you know, it is what it is, but good grief. I might need to get a little bit bigger persuader for this one. These guys seem to be in here pretty good. Yeah, I'm gonna go get a pick. Bear with me. Alright, so my journey back to the toolbox of many things has yielded us two options for picks. I'm going to try the bigger one of the two for starters because these things seem pretty stout. I'm trying not to poke myself in the eyeball with one of these. They seem to be only friction fit though, so I think they'll come out. Oh yeah, there we go. We're starting to get it loose, I think you guys can see. And I'm just going to work this guy around, loosen up all his little feetsies, and this guy should come right on out. There it goes. I said, come on now. Well, okay, be stubborn. I mean, this is your time we're wasting here, guy. I mean, the sooner you get done, the sooner I'm going to stop. I'm going to be able to stop jamming sharp objects into you. I mean, up to you whether or not you want to continue with this here pain. Ah, yeah! Success. Alright, come on out of there, you. Okay. Oh, look at there. There's another little thrust washer set up here. I don't know if I'll be able to actually pull this plunger completely out. Not without mangling it. Ah! Oh, well, I said that. I might be able to after all. Alright, thrust washer's out of the way. And then we have what appears to be our rubber back seal for the actual mechanism itself. Oh, diesel fuel everywhere. Good job, this is a clean shirt. Ooh, focus. Look at the gook on that. That's definitely 30 years old. Alright, let's look down at the bore here. I'm trying to get you guys in so you can see it. Might need a little bit of extra light here. Let me get that for you. Ah, there you go. See, look at that. So what actually happened in the failure mode with mine here is you see all that gook? That actually stuck it. It actually stuck itself in position. And this poor little stepper motor over here just wasn't enough to go ahead and yank that guy out. But would you look at that? Look at the schmoo. So, let this be a lesson to you. If you ever have one of these fail and it's stuck, if you're carefuler than I am, you might be able to pull it apart, put it back together, and actually make this thing go again. The simpler repair, obviously, being the stepper motor. But, let's talk about this thing real fast. This guy is essentially a two-way plunger valve. And the way it works is that this spring-loaded mechanism here on the back, let me move my light out of the way so you don't get as blind as I am. This little spring-loaded mechanism on the back actually holds the plungers. See? I'm moving them. And then if you notice, there is an opening in the middle and an opening on the side. So when this is in one position, fuel can flow one way. When it's in another position, fuel can flow another. Very, very cool.
YouTube, did you think it would be that easy this close to Halloween? When the ghost of Henry Ford comes forth to rail against modern technology and electrical systems go haywire. No, my friends, there's many more tribulations to come.